The fourth lab, the second problem, we're trying to show you a non-paired situation. So in the first question, you were talking about teaching one class both R and Excel, and then comparing them by testing the same class once with R and then once with Excel. Here, it's a different situation. Now there are two separate classes, and one class is taught only Excel, and one class is taught only RStudio. So you've got two different groups, and they're presumably not the same students, so you cannot pair them. So in the one case, you've got the same students that were taught both, and then they were compared to themselves. And then in the other situation here now, you've got two different classes. One class taught Excel, one class taught RStudio. So basically what we're saying here is we have a non-paired situation. Okay, so when uh, and what I want to do is to see if Excel was better than RStudio. Okay, so I'm going to download the data and load it. Here, let me just have a look at what it looks like. I've got here the student ID and their test in RStudio, and the student ID and their test in Excel. So what you can see here is this student ID does not match any of the student IDs in the other group. Okay, even though they have the same number of students, both classes have 20 students, they are not the same student in one group or the other. Okay, so what I would like to do now is to test the normality. So with the NOR test installed and loaded, let's see if both groups are normal. Okay, so in this case, I've got a small p-value, smaller than 5% for the RStudio group, and I also have a very small p-value for the Excel group. So in this case, it looks like neither of the groups is normal. If one of them was normal, but the other was not, I would still not be able to do a t-test. I would have to do the Mann-Whitney test. So in this case, both of them are not normal, so I'll have to do the Mann-Whitney test. But even if only one of them was not normal, I still have to do the Mann-Whitney test. The other thing to consider is if both sample sizes are large, then I can still do the t-test. So even though these are not normal, could I still do the t-test? And the answer, unfortunately, is not, because here, neither group is large. So if one group is large and normal and the other group is small and not normal, you would have to do the Mann-Whitney test. So if any of the groups is small and not normal, you would have to do the Mann-Whitney test. When you're doing the Mann-Whitney test, what you would do is you do Wilcox.test, you do the first group, you do the second group. And in this case, I'm trying to see if Excel is bigger than RStudio. So if I've put RStudio first and Excel second, and I want to see if Excel is uh, is the big one, then I would do the less than sign. Let me try and show you with drawing it out. So if I'm trying to see if Excel is bigger than RStudio, one nice way would just be to write the order. So when I'm doing here the Wilcox test, what I could have done is said this data that I called not paired. I could have chosen to use Excel as the first group. So if I put Excel first, then the sign is going to be the greater than sign. But if I don't put Excel first, if I put the RStudio group first, and I put the Excel group second, then the sign flips from being greater to being less than. Okay, so here, that's what I tried to show. If I had Excel first and RStudio second, the sign would be the greater. If I have RStudio first and the Excel group second, then the sign is not greater, it's the less than. Whatever the sign is pointing at, it needs to keep on pointing that way. So in this case, if I write RStudio first and Excel second, then I need to make sure that the sign is the less than sign, not the greater than sign. What's the value? The value is 0. Are they paired? The answer here is false. If I put false, I will get the Mann-Whitney test when I'm doing Wilcox.test. And if I say paired is equal to true, I'm going to get a Wilcox and signed rank test. So it's a big difference to whether you put paired true or not. The other thing that I need to do is make sure that I turn off the exact method. So I'm going to say false, and then I can put in the confidence level as I choose. I will get the test statistic as well as the p-value. Okay, so in this case, at least one of the groups was not normal, and the data doesn't have logical grouping, so that's going to be the Mann-Whitney test. How do I write the hypothesis for Mann-Whitney? I have to use the tildes on top of the mu's because I'm talking about medians, not means. What is the test statistic and what is the p-value? I just found those from R. And so then here the p-value is large, saying I'm going to reject, so it doesn't look like the Excel group was able to outperform the RStudio group. They are either similar or perhaps the RStudio group outperformed the other group. So here, one thing to make sure that you know that you realize that you're doing is you're not testing means in the Mann-Whitney, you're testing median. So because I've done Mann-Whitney, I can infer that the median of RStudio is not significantly lower than the median of Excel. If the data were normally distributed, then I could have either done a two-sampled test, pooled or not pooled. So if I would have found that it was actually normal, then I would have had to do Levene's to find if I'm doing this test or this test because they are not paired data.